Period.
Period. All right. So go look it up or see if you remember. I'm going to go get some water because chocolate. I'll be right back.
Anybody else wondering where the cat is?
Well, the cat is asleep. Minding its business.
But like, you know, she always says like the cat is like always in the room when we're on. So I want to know where the cat is.
It's not
What was that?
What?
Carl.
Oh, my this cat noise, I can't deal. So wait, Miss Baskin,
Yes, Sean.
for the lone electrons, we count them individually, right?
Who's lone electrons? What do you care about? What?
Aren't we doing, you said for hybridization, right?
Uh-huh.
Isn't that, oh wait, I just lied. I thought it said oxygen. It said carbon.
It did.
But then for the bonds, we count like double bond. It's just one bond. We don't care about the number of lines. Okay, so it's
Correct.
3. So 3.
No, it's too blurry on the phone.
Are we speaking out loud or are we writing it down?
Yeah, what is it?
SP2.
SP2. Because there are 3 domains around this thing. Right? So you've got 1, 2, 3. 3 domains is S, that's one of them, and 2. So 1 plus 2 is 3. So if you were having to memorize this, that's what you would, that's how you would memorize it. But you don't. You have your massively cute cheat sheet to be able to help you out there. Now, I know that's the only question they asked about this, but let's look at and think about what are some other things that you could be asked here. So looking at a diagram like this, how many sigma and how many pi bonds are there?
There are 2 sigma. No, I'm tripping. Are there? No.
7 sigma, 1 pi.
Yes, Cassidy. 1, 2, 3, 4, 5, 6, 7 sigma. Every bond is a sigma bond. And then in a multiple bond, the second or the third lines are pi bonds.
Oh.
Just the second or the third?
Yeah. So like that's a sigma, that's a sigma, that's a sigma, 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 and then that would be the pi.
Mm-hmm.
Another thing. So that's sigma and pi bonds. So we said that the carbon is sp2. What is the shape of this region?
Trigonal planar.
Uh-huh. Say it louder.
Trigonal planar.
Trigonal planar. All right.
Will we revisit that?
What?
Will we revisit that?
No.
Okay.
I'm like, it's on the magic chart. So all you have to do, Taylor, is look and see that I've got 1, 2, 3 things around it and no lone pairs. So you go look up in that chart and see what is the name of the thing that has 3 domains, right? And no lone pairs.
Miss Beth.
Okay.
Yes, Sean.
So, the chart, I don't know if like this is just this chart that was in the collaborative notes.
Mm-hmm.
It has geometry of electron pairs and geometry of atoms.
Mm-hmm.
So which one? Because like, so for instance, for the if it has two bonds and 1 electron, like it's still sp2 for the orbital hybridization, but it has trigonal planar geometry of electron pairs and bent geometry of atoms.
Mm-hmm.
Is that like, do we need to know like the difference? Or like when
you're always going to go with basically the bent, the individual thing, right? Because the first one is like the larger category,
Oh, okay.
of stuff. Yeah, but no, I
Okay.
know what you mean. Let me pull that up. So what would the geometry around the nitrogens be? Right? The carbon is trigonal planar, but what about the nitrogens?
Tetrahedral?
Yes.
Yay!
That's Wendy.
Well, the whole thing is tetrahedral,
Oh, well.
but because of this lone pair, the shape is actually specifically what?
Bent.
Trigonal planar.
Not trigonal planar.
I lied. Wait a second. T
Trigonal
shape?
pyramid? I don't even know why I said
Is it T shape?
No, it's trigonal pyramidal.
Oh, I
I'm sorry.
definitely. Wow. Here's the gag. I read it in the right place, and I definitely said trigonal planar, even though that's not what it says on the paper.
Okay.
But what?
Yeah.
I'm so confused. Why is it trigonal pyramidal?
No, it's not bipyramidal, it's just trigonal pyramidal. You start with the tetrahedral because you count 4 things, but one of them's a lone pair. So it goes from being tetrahedral to actually trigonal pyramidal.
I see it.
Okay?
Mhm.
Cool. All right, so that's that question. All right, so let's move on. And these are both questions from last year's tests. Okay, so the next one says, you've got all of these diatomic things, right? Bromine, chlorine, fluorine, iodine. Circle the formula of the molecule that has the longest bond length and justify your choice in terms of atomic structure. So first off, do all of these have single, double, or triple bonds, or is it a mix?
It's a mix. I think Cl might have a double bond.
All single.
They're all single. These are all halogens.
They're all.
So they all make single bonds, so that's not the difference. So figure out what is the difference and what would give you the longest bond length and how would you justify that?
Are we
Is
speaking
it-
or like writing it down first?
Is it size, atomic radius? Because it increases as you go down the group. So because
All right, so then
yeah.
who's biggest? Who would you circle?
Iodine.
As the biggest, iodine.
Iodine. All right, because if you have them in order on the periodic table, it's F, Cl,
WR and I.
Br, and I, right? So they gave them to you in a random order. So iodine is the answer. And then you need to justify your choice in terms of atomic structure. And I will say, again, justify means that you don't get the point for iodine if your explanation is not good. It is different than explain. If they say explain your choice, then they would be giving you a point for the iodine and a point for the explanation. So that's the difference between justify and explain. So I want you to come up with good language because I have a feeling that since this is going to be more of a written sort of test, they're going to be a little bit pickier on the explanations. All right, so who wants to give an answer?
I'll go.
All right, Carl?
Well, it's iodine because its atomic radius is the largest of 4.
Okay, so iodine has the largest
Atomic radius.
atomic radius. That is correct. How does that affect the bond length?
That means that the
nuclear-
distance between the molecules is larger.
So would you have to reference Coulomb for this?
No,
Okay.
not here. They typically say to reference coulombs if they want you to reference coulombs. They've gotten better about that. So the distance between the two nuclei is greater. So here, the tricky thing is it's not enough to say that iodine has the largest atomic radius. How does that affect the bond? You have to link the atomic radius to the bond. That's how you actually answer that question. So you have to link atomic radius to bond length. Kind of annoying, but it's those little details that I want to make sure we get right. Okay. The next question is from 2017. Another question where they've given you structures and they're asking you questions about them. So this is going to be our more standard type of thing. So here we've got two different structures, right? Tell us two possible Lewis dot diagrams for fulminic acid. Explain why the diagram on the left is better. So explain why the one on the left is better. Justify your choice based on formal charges.
Meaning oxidation.
No.
No.
I feel like you gave us this before.
I might have.
Isn't it where you do the H and then count how many bonds it has and then plus and then parentheses that thing?
Yes, I think Grace put the formula on the collaborative notes.
The valence electron thingy minus something.
Mm-hmm. So if you have to justify your choice based on formal charges, that means you need to calculate the formal charges for everything in both of these questions or in both of these structures. So do that first.
Yikes, it's gonna take a second. The lines, do we count individual lines or do we count like the bond?
Pretty sure it's individual lines.
Mm-hmm.
And there's also individual dots, right?
Yes.
Not the pair. Ms. Baskin,
Yes.
for this one, do you want us to wait to give answers? Or?
Yeah, give me just a second.
Okay.
Oh, that one's, I did that wrong. That's why I was like, wait a minute. Three. Yeah. There we go. That makes more sense. All right, did you get that for the formal charges?
Yes.
Yes.
Okay, so in this question, because it's an explain question, 1 point was awarded for the formal charges, for assigning them, and then a second point is awarded for using the formal charges to justify why the one on the left is better. So using the formal charges, how would you say that the one on the left is the better representation?
I said the diagram on the left is better because although the diagrams have equal formal charges in total, the one on the left gives O, the most electronegative element, the negative formal charge.
That is the answer. All right. So you have to say that the more electronegative element, oxygen, carries the formal charge of -1 on the left, right? So that's the important part. So, because everything else is, as what Sean said, everything else being equal, like they both total up to a value of 0. So that part is correct. The only difference between them, because in both of them, right, nitrogen is a +1 in both of them. So the only difference here is that the oxygen is a -1 versus the carbon is a -1. That is literally the only difference between these two structures. And so you have to look at that and say oxygen is more electronegative, so that is the thing that is correct. That is not going to be correct. Does that make sense?
Mm-hmm.
Yes.
Cool. Look at us blazing through these. All right. Next. Let's talk about some lattice.
Latrice.
All right. So says the energy required to separate the ions in the magnesium hydroxide crystal lattice into individual magnesium and oxygen ions, as represented in the table below, is known as the lattice energy of magnesium hydroxide. As shown in the table, the lattice energy of strontium hydroxide is less than the lattice energy for magnesium hydroxide. Explain why in terms of periodic properties and Coulomb's law. So that's why I said if they want you to use Coulomb's law, they will tell you to use Coulomb's law. So you have to look at these two things and decide based on the factors that are in play in Coulomb's law, why is this value smaller than this? Go.
So, Ms. Baskin,
Yes, Kayla.
so with Coulomb's law, there's charge and then there's distance.
Yes,
By
ma'am.
charge, do they mean like electronegativity or do they mean like?
+2, -1.
Okay. Okay.
So, Miss Baskin,
Yes, ma'am.
is it like has something to do with because magnesium's atomic radius is smaller than that of strontium's?
Yes, it does.
And because like strontium, okay, hold on. Because let me think about it. Let me formulate my words.
Ms. Baskin, I did have a question. So, or I know you're going to do it, but I just need to make sure you go over how to, because I think my answer is right, but I think that, me, it's real wordy. So I want to figure out how to like concisely say what I need to say to get the points.
Okay. So I would look at this and say, it says explain why in terms of periodic properties and Coulomb's law, and say, okay, so I'm gonna write 2 bullet points, right? One bullet point is gonna say something about the periodic property, and the other bullet point is gonna say something about the Coulomb's law. So
Okay.
in that instance, your first bullet point on periodic properties, what periodic property is in play here if I'm making a comparison between these 2 things?
Atomic radius.
Atomic radius.
All right, you could either say atomic or ionic radius, right? So so that's what you need to say. And what is the important factor there? You can say it one of 2 different ways here. You can either say one is smaller or one is bigger.
Yeah, magnesium its atomic radius is smaller than that of strontium's.
So that's
Okay,
really strong.
so magnesium has a smaller radius than strontium. Don't write out the full words. There's no reason to, just use symbols. And how do you know, or why do you know that magnesium is smaller than strontium?
Based on the periodic trend as you move down a group.
Nope, you cannot talk about location on the periodic table. You actually have to talk about the actual physical structure of the atom.
Oh, okay.
There's less protons.
It's
Has
Oh,
less.
It has less.
Magnesium have less orbitals?
Yeah, so yeah, Carl and Wendy saying the same thing. So magnesium has a smaller radius than strontium because it has fewer energy levels. It has fewer orbitals. They will take a large number of terms there. Okay, so that answers the periodic properties bullet point.
okay.
And then the second one, you have to use that information in Coulomb's law. So Coulomb's law could be 2 things, as Kayla said. It can be charge or it can be distance. So which thing is not in play?
Charge.
Charge. They have the same charge. You don't have to mention that they have the same charge. That doesn't matter. So you just have to talk about the thing that's different.
Kayla, what's going on?
You have to talk about the distance again.
Yes.
Okay, so I said that
And now Carl.
SR's atomic radius is bigger, so their bonds are weaker, so it's easier to break. So there will be less energy released when they're taken apart.
Almost 100% there. So you have to say the distance between what?
The nuclei.
All right, so it is, okay, so if you're going to answer it from strontium's perspective, you would say, since strontium is bigger, there is a greater distance between ions.
Okay.
Because Coulomb's law is all about ions.
Okay.
Between ions. So there is, what does that mean for attraction?
Weaker.
That's weaker.
So there is weaker or less attraction in the bond. Requiring less energy to separate.
Right.
Now, you can also answer it from the perspective of magnesium. It doesn't really matter which way you do it because it doesn't technically specify. So if you were going to write it from magnesium's perspective, what would you write?
Smaller
Yeah.
atomic radius means a smaller distance between the ions, which means there's a stronger attraction in the bond.
Yes, since magnesium is smaller, there is a smaller distance between ions. So there is stronger or more attraction in the bond, requiring more energy to separate. So both of those answers are completely acceptable because they're answering the exact same thing. All right, they're saying the same thing. So you have to remember that in a Coulomb's law question, you have to talk about either charge or distance, whichever one is at play, and then relate that to attraction, and then relate that to the question. So it's always you have to say all three of those things, which is kind of annoying, but that is the way it is. So that's something that you guys might want to put on your collaborative notes thing, that if you're going to answer a question about Coulomb's law, you have to have 1, 2, 3 parts to that answer to make sure you get the points. Because it's not a hard question. Like, you can get it, you know it, but the only thing that you'll fall apart on is not answering all of the pieces, making the assumption that the grader is just going to know that you're jumping from this to this, and therefore that means that. No, you have to be explicit.
So, Ms. Bassi,
Yes.
I know I'm kind of backtracking, but how do you know in a problem whether they want you to talk about, like, is saying periodic trends versus periodic properties different? Like, if they were to say periodic trends, is that when they're looking like as you move down a group or as you move across a period?
They, at the AP level, they're never going to want a simplistic enough answer as because this is closer to fluorine.
Okay, got you. So you always have to go like it has more orbitals.
You always got to be extra. Yeah.
Okay.
Yep.
Okay.
Yep. Okay. And then the last question that we have is from 2016. And this is an example of a diagram where, again, they are asking you questions. So there are 2 questions here. One says, which salt, LiCl or NiCl, has the greater lattice enthalpy, and justify. And again, justify means that is a 1-point question, and you get 1 point for picking the correct answer and the explanation, because otherwise they're not going to give you 1 point on a 50-50 guess. So that's how you know that's a 1-point question. And then the second question is, below is a representation of a portion of a crystal of LiCl. Identify the ions in the representation by writing the appropriate formulas in the boxes. Now, do note that they told you what it is they want in the box, so you make sure that you write the thing that they want in the box. So don't just write Li or Cl. You have to write it with the ion charge. They did provide the ion charge. So
Draw outside the box.
Yep. So we can answer D down here, and E is simply putting those in.
So for the sizes of the 2 circles, that's based on the atomic radius, right?
Or the ionic radius, but the ionic radius is based on atomic radius. So yeah.
Yes. Okay, cool.
Mm-hmm.
Miss Baskin, would Cl be bigger?
You tell me.
Okay. I
Wait,
think it
is this a rhetorical or is this an actual question?
What, Kayla's question?
No, like, I mean, do you want us to actually answer or do you want to think about us to think about it?
I mean, does somebody want to answer Kayla's question?
Isn't it smaller?
No, it's bigger.
As you move across the
Bigger
thing,
because it's 7. No, it's talking about atomic rate. Oh, you're talking about the size of the
the
structure.
actual atom, right? A Cl atom would be
Cl is bigger
because it has more
atomic rate
electronegativity,
is
isn't it?
I mean the what you call them is 7 thing, I think.
Look at the number of energy levels. Look at the period numbers there.
Oh, I'm talking about valence electrons, but I know Cl bigger anyways.
It is.
But I thought we said, oh, so is it based, okay, so as you move across a period though, like if I was looking at like NaCl,
Mm-hmm.
Na is bigger than Cl
Yes.
because Cl is more like tight knit.
Yes. However, but we're talking about the ions.
Yeah.
So Na plus is smaller because it lost something, right? So it shrank.
Yeah. Okay.
And chlorine, since it gained something, got bigger.
Okay,
but
gotcha.
here it's even easier because what period is lithium in?
2.
Period 2. And what period is chlorine in?
3. So
3.
2 is automatically smaller.
Yeah. And so I said that the bigger factor, as opposed to love, the bigger factor is up down. So chlorine being further down is automatically going to be bigger. So which one of these? So which one of these boxes is the chlorine? The one on the left or the right?
The left.
The left. That's your Cl minus. That's your Li plus.
Can I tell you my explanation so I can see if it's right?
Yes.
I'm talking about for the first one.
Yeah, for D.
Mm-hmm. Yeah. All right. I said it was LiCl because it has a smaller atomic radius than NaCl, and it's because it has less orbitals, and since Li is smaller, it's a smaller distance between the ions, so it's a stronger attraction in the bond.
Yep, all of that.
Yay, I was right.
Yep, because you did the thing, right? So you said that, first, Li is smaller than Na, right?
Mm-hmm.
And then so that means that there's Li has more attraction in the bond. And that means more energy needed to break, right? So those are your 3 parts of anything to be able to use Coulomb's law.
Miss Baskin.
Yes, Sean.
So, I'm sorry. When we say lithium is smaller than Na,
Mm-hmm.
do we have to reference, like, I guess in wording of questions, how do you, like, so before, right, but we had to say, like, Mg is smaller than strontium because it has less energy levels, stuff like that. Do we need to also reference energy levels here, or can it just be as simple as it's smaller?
It can just be as simple as it's smaller because they didn't specifically ask for that. So in the question where they wanted it, they said, explain it based on this and this. Okay,
got you.
Yeah. So you can also tell that this is an older question and that other question was a newer question because they're trying to be more specific and say, no, I want your explanation based on this specific thing. Tell me based on this thing. So that's one thing that they've been doing better with. Okay, so that is that's the last one I have.
I feel like I'm better prepared for this unit than I was before.
So what was I gonna say? So you've got the collaborative notes to finish adding to, then the multiple choice and the free response questions on AP Classroom, and that's it.
Oh wait, Miss Baskin.
Yes,
Can we
ma'am.
figure that out later today?
Yes,
Maybe?
yes, yes. All right, so if
yeah.
anybody has questions, cool. Otherwise, have a lovely weekend.
You too.
Bye.
You too, Miss
Miss
Baskin.
So what are you
Thank
doing?
What the heck?
No, okay. So when Cassidy was giving her response, there was some volume something going on in somebody's background. And it was really funny to me. And then I looked at Kayla's picture. Kayla was cracking up.
Kayla's still cracking up. I'm not sure if she's breathed yet.
Because I just texted her. This is too much. It was just really funny. I'm sorry.